Fresh observations of 3I-ATLAS are now shedding light on this mysterious interstellar visitor, and what scientists are discovering challenges everything we thought we knew about cosmic wanderers. With a trajectory that defies astronomical odds and behavior patterns unlike any natural object, this ancient visitor raises profound questions about its true nature. Could humanity be witnessing something far more extraordinary than just another comet? Discovery and initial detection. What if the most significant discovery in human history almost slipped past us unnoticed? 3I-ATLAS was discovered on July 1, 2025 by the ATLAS telescope in Chile, initially receiving the mundane designation A11PL3Z before astronomers realized they were observing something unprecedented. This marks only the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019, making it an extraordinarily rare cosmic event. The object had actually entered our solar system much earlier, but its challenging viewing angle near dense star fields delayed detection until it was already well within the inner solar system. Late detection meant crucial observation time was lost, similar to what happened with Oumuamua, when humanity missed the opportunity for detailed study. The discovery team quickly recognized unusual motion patterns that didn't match typical solar system objects, prompting immediate follow-up observations from telescopes worldwide. Within 24 hours, NASA confirmed its interstellar status, officially designating it as C/2025N1 and awarding it the historic 3Y designation. This rapid confirmation process demonstrated how much astronomical detection capabilities have improved since Oumuamua's controversial discovery 8 years earlier. Extraordinary orbital characteristics. How can an object's path through space defy the very laws of probability? 3I-ATLAS follows a hyperbolic orbit with an extreme eccentricity of 6.14, the highest recorded among all known interstellar objects, far exceeding Oumuamua's 1.2 and Borisov's 3.6. This incredible trajectory brings it racing through our solar system at 58 kilometers per second, making it the fastest interstellar visitor ever recorded. Most remarkably, its trajectory lies almost perfectly in the ecliptic plane, with astronomers calculating only a 0.2% probability of this occurring by random chance. The ecliptic alignment means the object travels along the same plane where all planets orbit, providing optimal viewing opportunities for studying multiple worlds during a single passage. This path appears deliberately designed for comprehensive planetary reconnaissance, rather than the random trajectory expected from a natural ejected object. The orbital mechanics suggest the object has maintained this precise alignment throughout its potentially millions-year journey through interstellar space. Such mathematical precision in trajectory raises fundamental questions about whether natural gravitational interactions could produce such an unlikely path. The combination of extreme speed, perfect ecliptic alignment, and record-breaking eccentricity creates a statistical anomaly that challenges conventional understanding of interstellar object behavior. Suspicious planetary encounters. What are the odds that a random space rock would visit exactly the planets most interesting to an alien intelligence? During its passage through our solar system, 3I-ATLAS approaches unusually close to Venus, Mars, and Jupiter, with astronomers calculating the probability of such precise planetary encounters at just 0.005%. The object passes within 0.65 astronomical units of Venus, 0.19 AU of Mars, and 0.36 AU of Jupiter, distances that would allow detailed study of each world's atmospheric composition, magnetic fields, and potential habitability. Perhaps most intriguingly, its closest approach to the Sun occurs precisely when Earth is positioned on the opposite side, blocked from direct observation during the most critical phase of its visit. Scientists estimate only a 7% probability that this solar eclipse timing would occur naturally. The trajectory resembles a carefully planned reconnaissance mission designed to gather maximum information about our solar system while minimizing detection risks. Each planetary encounter occurs at optimal distances for advanced sensors to collect detailed data without triggering obvious gravitational perturbations that might reveal artificial propulsion systems. The visiting pattern suggests intelligence rather than random cosmic wandering, following protocols that hypothetical alien explorers might use to study potentially inhabited star systems. This systematic approach to planetary surveys raises profound questions about the object's true purpose in our cosmic neighborhood. Physical properties and anomalies. How can something be simultaneously ancient beyond imagination, yet perfectly preserved for scientific study? Recent observations by the Vera C. Rubin Observatory reveal that 3I-ATLAS measures somewhere between 1 and 12 kilometers in diameter, making it, well, significantly larger than previous interstellar visitors, and potentially the biggest object of its kind ever observed. Age estimates suggest this cosmic wanderer is over 7 billion years old, predating our entire solar system and maybe even preserving materials from the early universe, back when galaxy formation was fundamentally different. Despite its extreme age, 3I-ATLAS appears remarkably well preserved, showing none of the expected degradation from billions of years of cosmic ray bombardment and micrometeorite impacts. The object exhibits the brightest absolute magnitude of any confirmed interstellar visitor, making it unusually reflective or possibly even internally illuminated compared to typical space debris. Its 29-hour rotation period with minimal brightness variation suggests either perfect spherical symmetry or an artificially stabilized spin rate, which really contrasts sharply with the chaotic tumbling you'd expect from natural ejected objects. The surface appears unusually smooth and uniform, lacking the irregular features you usually see on asteroids or comet nuclei shaped by countless impacts during interstellar travel. These physical properties create a profile more consistent with manufactured technology than natural formation, challenging scientists to explain how ancient materials could remain so pristine after eons of cosmic exposure. Comet-like features versus anomalous behavior. Why does this supposed comet behave unlike any other comet in recorded astronomical history? 3I-ATLAS displays a faint coma and a short tail measuring about 3 arcseconds, confirming active outgassing typical of comets approaching the Sun. Yet these features appear far more subdued than you'd expect for an object of its size and solar proximity. The coma appears compact and dense, rather than the diffuse, fuzzy appearance characteristic of normal comets, which suggests either an unusual composition or maybe even artificial containment of expelled materials. Most puzzling, the object lacks the prominent tail that should develop as it approaches perihelion, with only minimal dust ejection, despite receiving substantial solar heating. Spectroscopic analysis reveals water ice signatures, but the patterns just don't match expected models, with observed signals rising where theoretical predictions indicate they should actually drop. The outgassing appears controlled and limited, almost as if internal systems are regulating material release rather than allowing natural sublimation processes to proceed unchecked. Unlike typical comets that become increasingly active and chaotic as they near the Sun, 3I-ATLAS maintains remarkably stable behavior and appearance. The reddish coloration resembles outer asteroid belt objects more than pristine interstellar ice, suggesting complex surface processing or perhaps manufactured coating materials. These contradictory characteristics create a hybrid profile that fits neither pure comet nor asteroid classifications, demanding new explanatory frameworks for understanding interstellar visitors. Scientific debate: natural versus artificial. How do scientists reconcile extraordinary evidence with the burden of extraordinary proof? Professor Avi Loeb from Harvard University has publicly suggested that 3I-ATLAS could represent artificial technology, pointing to its statistically improbable trajectory, perfect timing, and anomalous physical properties as evidence warranting serious consideration of alien origins. Loeb argues that dismissing artificial possibilities without thorough investigation violates scientific methodology, especially when natural explanations fail to account for observed characteristics. However, many mainstream scientists dismiss these claims as irresponsible speculation that damages public trust in astronomical research and diverts attention from legitimate scientific study. Chris Lintott from Oxford University called the alien hypothesis nonsense, emphasizing that extraordinary claims require extraordinary evidence that simply doesn't exist. The debate centers on fundamental questions about scientific methodology. Should researchers explore all possible explanations, even seemingly outlandish ones, or maintain conservative approaches that prioritize conventional interpretations? Critics argue that entertaining alien explanations without definitive proof encourages conspiracy theories and undermines scientific credibility. Supporters counter that science advances by challenging assumptions and investigating anomalies that don't fit established models. This controversy reflects broader tensions within astronomy about how to balance open-minded inquiry with rigorous skepticism when confronting potentially paradigm-shifting discoveries. The scientific community remains divided on whether 3I-ATLAS deserves conventional analysis or represents something requiring entirely new investigative approaches. Spectral analysis mysteries. What secrets hide within the light signatures that challenge our understanding of interstellar chemistry? Spectroscopic observations using the Gemini S telescope and NASA IRTF reveal that 3I-ATLAS contains abundant water ice, but the spectral patterns, well, they exhibit puzzling characteristics that don't match theoretical models for natural comet composition. The optical spectrum shows about 10% reddening per 1,000 angstroms, which actually resembles D-type asteroids more than typical ice-rich comets. This suggests either some pretty unusual formation conditions, or maybe even artificial surface treatments. Moving on, the near-infrared analysis flattens to 3% per 1,000 angstroms, indicating large water ice grains. Yet the expected 1.5 micron water band is mysteriously absent, even though there are strong signals at other wavelengths. Scientists have managed to model the spectrum using 70% Tagish Lake meteorite material, combined with 30% water ice. But honestly, this composition seems inconsistent with objects formed in distant stellar systems billions of years ago. The spectral stability across 9 days of observation suggests remarkably uniform surface properties, which is in contrast to typical comets that show variable composition as different regions become exposed to solar heating. Color measurements through various filters confirm persistent reddish characteristics, indicating complex organic materials that could potentially preserve chemical signatures from alien star formation environments. However, the isotopic ratios and elemental abundances appear surprisingly similar to solar system materials, and that really raises questions about whether this truly represents pristine interstellar matter, or, well, something a bit more familiar. These spectroscopic puzzles demand new theoretical frameworks for understanding how interstellar objects preserve and modify their original compositions during million-year journeys through the galaxy. Dark forest hypothesis implications. Could 3I-ATLAS represent humanity's first encounter with the terrifying cosmic game theory known as the dark forest? This hypothesis suggests that intelligent civilizations throughout the universe remain hidden and silent, maintaining strict stealth protocols to avoid detection by potentially hostile species that might eliminate competitors before they become threats. 3I-ATLAS exhibits stealth-like behavior perfectly consistent with reconnaissance missions designed to study planetary systems while minimizing detection risks and exposure to defensive responses. The object's trajectory allows comprehensive solar system surveys while remaining hidden behind the sun during its most vulnerable closest approach, when any artificial systems would be most easily detected. Its deliberate timing ensures minimal observation opportunities during peak activity, following protocols that advanced civilizations might use for cautious exploration of potentially dangerous inhabited systems. The dark forest theory predicts that alien visitors would conduct rapid, efficient reconnaissance missions to assess threat levels and resource availability before deciding whether to establish contact, eliminate competition, or simply avoid detection entirely. 3I-ATLAS's behavior matches theoretical predictions for how intelligent species might approach unknown star systems, gather maximum information while maintaining escape routes and avoiding confrontation. The object's ancient age suggests it could represent technology from civilizations that achieved interstellar travel billions of years ago, when the galaxy was younger and potentially more hospitable to life. If this interpretation proves correct, humanity may be experiencing our first contact with alien intelligence, but contact designed to remain undetected until the visitors can assess whether we represent friends, enemies, or irrelevant primitives. Historical context and lessons. The arrival of 3I-ATLAS provides crucial insights gained from our previous encounters with interstellar wanderers and the opportunities we missed. When 1I Oumuamua was first spotted in 2017, the astronomical community was completely unprepared for studying such an extraordinary phenomenon. Robert Warwick, who made the discovery using the Pan-STARRS 1 telescope in Hawaii, has acknowledged how the object's swift departure left numerous fundamental questions permanently unanswered. The enigmatic acceleration that Oumuamua displayed without any visible cometary activity continues to baffle scientists today, demonstrating the critical importance of immediate and comprehensive observation protocols. 2 years later, Gennady Borisov discovered 2I Borisov from his private observatory in Crimea, giving astronomers a valuable second opportunity that was better managed but still limited by technological constraints. Mark Norris from the University of Central Lancashire has stressed that 3I-ATLAS represents our most significant chance yet to conduct thorough studies of an interstellar visitor, using cutting-edge instruments and globally coordinated observation campaigns. The enhanced detection systems of modern sky surveys, paired with instantaneous global communication networks, have enabled unprecedented real-time collaboration among observatories worldwide. These hard-learned lessons from previous interstellar encounters have fundamentally transformed how the scientific community approaches these exceptionally rare cosmic events. Future observations and implications. Will the next few months provide humanity with definitive answers about 3I-ATLAS's true nature, or deepen the mystery forever? Perihelion, on October 30, 2025, offers scientists their best opportunity to conduct comprehensive analysis before the object begins its final departure from our solar system. Multiple telescopes worldwide are coordinating unprecedented observation campaigns using every available technique, from radio astronomy to gravitational wave detection, ensuring no potential evidence escapes analysis. The object will re-emerge from behind the Sun in December 2025, providing a final observation window to confirm or refute artificial origin theories before it disappears into interstellar space forever. Advanced space missions including MAVEN, Mars Reconnaissance Orbiter, and the Jupiter Icy Moons Explorer will attempt close-range observations during planetary encounters, potentially revealing surface details impossible to detect from Earth. Scientists are developing new analytical techniques specifically designed to distinguish between natural and artificial objects, creating frameworks that will guide evaluation of future interstellar visitors. The comprehensive data collection from 3I-ATLAS could revolutionize understanding of interstellar object populations, formation mechanisms, and the potential prevalence of alien technology in our galactic neighborhood. These observations will either definitively prove 3I-ATLAS is a natural comet, ending speculation about artificial origins, or provide evidence that fundamentally changes humanity's understanding of our place in the universe. The implications extend far beyond astronomy, potentially affecting planetary defense strategies, international space cooperation, and humanity's long-term preparation for contact with alien intelligence. Future detection systems are being designed to identify similar objects much earlier, providing years rather than months for detailed study and potential interaction. As 3I-ATLAS continues its enigmatic journey through our solar system, scientists race against time to unlock its secrets before it vanishes forever. Whether this ancient visitor proves to be a natural relic from distant stars or something far more extraordinary, its discovery marks a pivotal moment in humanity's cosmic awareness. The truth about 3I-ATLAS may reshape our understanding of life, intelligence, and our place in the universe. Stay curious about the cosmos with Simply Science. Like, share, and subscribe for the latest discoveries from the edge of human knowledge.